about how an inequality can be viewed as a constraint in a problem situation. And constraint just means it's going to limit things. Each solution of the inequality represents a combination that meets the constraint. And then here's the really important part. In real-world problems, the domain and range are often restricted to non-negative or whole numbers. Okay, so if we're talking about number of people, we can't have like 0.5 or like a negative amount of people. That's what this is saying right here. So let's look at a real-world situation. We've got a yearbook company promised to give the junior class a picnic if they spend at least $28,000 on yearbooks and class rings. Each yearbook costs $35 and each class ring costs $140. The question I'm trying to answer is how many yearbooks and class rings must the junior class buy to get to their picnic? And I've got two variables here because I want to know how many yearbooks and how many class rings must they buy. Notice they don't have to buy the same amount of each. So I'm going to have y equals the number of yearbooks. And I'm going to let c equal number of class rings. And just to make things easier, I'm going to cross out this x on my x-axis, and I'm going to label it a c. So now I know this axis is talking about yearbooks. This axis is talking about class rings. And now what do I know? Well, I know that they have to make at least $28,000. So my amount has to be greater than or equal to $28,000. And each yearbook costs $35. So that means that if I take 35 times the number of yearbooks, this will give me the total value of my yearbooks. And then if I add on the total value of the rings, which would be 140 times the number of class rings, I know the total value of the yearbooks plus the total value of class rings has to be greater than or equal to 28,000. And now what I'm going to do is I'm going to solve this for one of my variables. I'm going to solve it for y, and you're always going to want to solve this for whatever variable is on your y-axis. Y is on my y-axis, so I'm going to solve this for y. Start out by subtracting 140c. And notice here, c is just like my x value. Notice it's on my x-axis. So I get 35y equals negative 100, sorry, not equals. 35y is greater than or equal to negative 140c plus 28,000. And then I'm going to divide each side by 35. And I get y is greater than or equal to 140 divided by 35, which is 4. So I get negative 4c plus 28,000 divided by 35, which gives me 800. And now here's where it gets a little tricky to graph these, okay? Because I don't want to go up to 800 on my y-axis, but what you can always do is you can change the scale. So I'm going to say c is just going to go up by 1, 2, 3, 4, but I'm going to say my y-axis goes up by hundreds. 100, 200, 300, 400. And you don't have to label it all the way up, because if somebody would look at it, they would go, okay, 100, 200, 300, 400. This must be 500, and so on. So just start out labeling them one way so people know what's going on. So now my y-axis is 800, or my y-intercept is 800, so I'm going to put my point there. And now my slope is down 4 over 1. So I'm going to go down 4, which really doesn't look like I'm going down at all because these are going by 100s. Do not make the mistake of going down 4 over 1. Okay? Remember that we're going by hundreds, so you're really not going down at all. And this doesn't have to be perfect, it's just got to be close. And notice, it's greater than or equal to, which means I have a solid line. So I'm going to graph a solid line. Now I just need to test a point. It's always easiest to test 0, 0. So I see, is 0 greater than or equal to negative 4 times 0 plus 800? Well, is 0 greater than or equal to negative 4 times 0 is 0, plus 800 is 800. Is 0 greater than 800? That's false, which means if it's false, I shade on the opposite side. So you would probably just want to go ahead and shade like this. The only thing is, here's what we need to think about it being a real-world situation. If I shade over here to the left of the y-axis, I'm actually shading for negative numbers of class rings, which doesn't make any sense. So when you have a real-world situation, you have to make sure to not shade negative numbers if they don't make sense. So actually your answer would look something like this. And now, what would be a possible solution? Well, if I go to 4, 800, I can see that 4, 800 is clearly graphed. So if they sold 4 rings and 800 yearbooks, that would be a possible solution. Everything that's shaded is a possible solution. That's all there is for this lesson. Okay, graphing the line is exactly the same as what we've done before. The only new thing is the shading. As always, let me know if you have any questions.